Alright, we're back. And with the problem we left off on, we're going to evaluate the 6 trig values at this point, 17 pi over 6 radians. Where is that? Well, pi is 180, 2 pi is 360. This goes around more than once, we can tell. So let's count by what is pi over 6. Here's how I like to look at it. Ignore the 17. Pi over 6 is the angle that it takes 6 of them to get here. Well, you probably think a little bit more along the lines of degrees, so that you have to figure out that's 30 degrees, pi over 6, and you have 17 of them. 6 of them to get here, 12 to get here, so this would be 12 pi over 6. This would be 18 pi over 6. So we're not quite there, we're only 17. So you can tell we're right up here. So if it helps you to see this with a circle, I'll put the circle here for you. Good enough. And so we figured out that we're dealing with this picture right here. What I basically did was I'm dividing by 2 pi, because that's how many times around I go. Well, if you divide by 2 pi, 17 pi over 6 divided by 2 pi. So yeah, if you divided it by 2 pi, you'd get like 1.58, which would tell you go 1 and almost 1.5 times around the circle. But I think the way that I showed you here, counting by pi over 6, it takes 6 of them to get here. It takes 12 pi over 6 to get here. 13, 14, 15, 16, 17, it would take 18. So however we do it, we can figure out that this is going to be a 30-degree angle. This is going to be 60. This is going to be 90. We pencil in our sides, 1, 2, square root of 3, but this one's negative. And we can quickly figure out the sine of 17 pi over 6, cosine, the tangent, and we'll then do the inverses of those. So the sine, opposite over hypotenuse, is 1/2. Good enough there. The cosine, adjacent over hypotenuse, is negative square root of 3 over 2. Lovely. The tangent, opposite over adjacent, that's 1 over negative square root of 3. When I rationalize, that's going to become negative square root of 3 over 3. Now we'll do the inverses of those. The cosecant, that's going to be 2, because the reciprocal of 1/2. The secant of 17 pi over 6. The reciprocal of this is going to be negative 2 over the square root of 3. When I rationalize that, I'll get negative 2 square root of 3 over 3. And the cotangent of 17 pi over 6 is going to be the reciprocal of that guy, which I'm going to take the reciprocal of this one right here, and I'm just going to get negative square root of 3. So I'd like to do a quick demo that this is actually right. Make sure we're in radian mode, which we are, because I'm entering these in radian form. So the sine of 17 pi divided by 6.5, that's what we should have gotten. We'll take a look at the cosine of 17 pi over 6. And I get the equivalence of negative square root of 3 divided by 2. I want to show you that's the same thing. Negative square root of 3. Forgot the negative in there. Let's insert it. divided by 2. Same decimal. Okay, so that's showing you that that's what this is equal to. And the tangent, I could do the same thing there. But let me go over here and show you how to type in the cosecant. Cosecant is 1 over sine. So in our calculator, we'll type in 1 divided by the sine of 17 pi over 6. I get 2. And you can type in this one as 1 divided by the cosine of this. You can type this one in as 1 divided by the tangent. So that's how we'll find the 6 trig values at basically anywhere, no matter how many times we've wrapped around this circle. We should be able to use the fact that the period is 2 pi, or we can just count the way I did. Pi over 6's, and you count 17 of them out. Figure out where you are, what quadrant, draw the triangle in there with the correct reference angle. Don't get the 60 and the 30 mixed up. Make sure you got the right one in the right spot. Don't miss the negatives if there are any. Don't forget the hypotenuse is always positive, and then we just do our SOHCAHTOA. It's pretty straightforward once you get the hang of it. We'll do the same thing here for pi over 2. Now, pi over 2, where is pi over 2? Hopefully you recall that that is 90 degrees. So when we look at pi over 2, we throw a circle on there. We're talking about the top of that circle right up there. So, right here, and let's use the unit circle. Oops. So with this unit circle, this coordinate up here is 0, 1. And so we remember that the sine at these 90-degree locations, whether it's 90, 180, 270, or 360, we're just going to use the x and y coordinates at those points. Well, sine, because in this triangle, if I was to draw a triangle for any particular point on that circle, this is any ordered pair xy. Remember, this is the x, this is the y, this is the unit circle, so that's 1. So sine of an angle is y over 1, which is y. Cosine is x over 1, which is x. So the sine is just going to be the y value of 1 right here. The cosine is going to be the x coordinate of 0. The tangent is going to be the y over the x, or the sine over the cosine, which in this case is undefined. The cosecant is going to be the reciprocal of this, which is still going to be 1. The secant is going to be the reciprocal of this, which is now going to be undefined. And the cotangent will actually be defined, because here we said that the tangent was y over x, which was sine over cosine, which was 1 over 0. Well, the reciprocal of 1 over 0 is 0 over 1. So I'd like to verify this with you. Again, note, I am still in radian mode. We'll clear this stuff off of here. And we'll type in the sine of pi over 2. That's like doing sine of 90 degrees if you're in degree mode. We get what we thought we had. They are who we thought they were, right? Cosine of pi over 2. We should get 0. And the tangent of pi over 2, we should get an undefined. Error. There we go. That's what we thought we'd get. Let's go over here with cosecant. How do I type that in? That's the inverse of sine, so I type in 1 divided by the sine of pi over 2. I get 1. There we go. The secant is 1 divided by cosine. That's going to be undefined. All right. And the tangent, the cotangent is 1 divided by the tangent of pi divided by 2. And we should get 0. I forgot, oops, sorry about that. I'm sorry about that one. I'll have to fix that one later. Sorry about that. So, there we have that. Using the 90-degree locations around the circle. And any multiple of them. It could be pi over 2, 2, 3, 4, 5 pi over 2, 6 pi over 2, 7 pi over 2, whatever it may be. It could be around 50 times. It could be negative. As long as it lands at one of these 4 locations, we can use this technique right here. Alrighty. I'm going to conclude this video here. This is the last one of this multi-section assignment. I'm going to put an assignment here that is going to be a bit lengthy. Actually, you know what I'm going to do? I'm going to give it to you in class. I'll put that up in class. It's going to be an assignment over all 3 of these sections, 4.2, 4.3, and 4.4. We'll take a couple days to get that done, and then we will get into graphing the sine, the cosine, the tangent, and their inverse functions, along with periodic shifts and vertical shifts and all the good stuff. So this will be the end of this. Hopefully you've watched at least one of these by class time, and we can take it from there.